Hello, it's July 18th, and we're in our first discussion of Chapter 3 in Cohort 4. So before we go to any questions or anything, does anyone want to just bring up any overall thoughts they had on Chapter 3? Just about the chapter, where it is in the book, or what they remember or got from that chapter.
Yeah, I would add that I actually just generally think the chapter was written very well and it was very clear. I think the high road can be philosophically and mathematically very abstract. So I personally appreciated the kind of clarity that the authors took to discussing things like Markov blankets and existential imperatives. I guess it's the high road, perhaps more than the low road, provokes further questions, further ontological and philosophical, metaphysical questions. You know, how deep does the hierarchy of Markov blankets run, or what's the fundamental base layer of this this whole system? But on the whole, at least insofar as the free energy principle is a very simple explanation of something very fundamental, yeah, I thought they did a really good job outlining that particular point.
Nice, thank you. Anyone else? Any thoughts? Low road, high road, anything? Yeah.
Yeah, I really enjoyed this chapter, probably because there's less equations to get hung up on. But especially section 3.7, just the idea of using active inference to reconcile different theoretical perspectives. So in my area, action, we have debates about whether movement commands are represented centrally versus self-organizing or inactive. This is hotly debated for decades now. And that's something that's really attracted me to active inference, is to have a more unifying view rather than keep going with debating. So I really appreciated section 3.7 for me personally.
Any other thoughts on 3, or about how somebody is seeing the low road and the high road?
Well, Daniel, I want to see about the figures. When I look at the figures, for example, figure 3.1, where the figure explains the blanket states. But in addition to those blanket states, there are many other like notations and formulas. So it seems quite intimidating, those formulas. Like for example, the first equation on the left, you have x, dot x equal to f of x, etc. So all those notation is not explained. That's, it seems to me that it creates blocks for understanding of the concepts. So basically, I found it's kind of a little bit incomplete. I know it's difficult because in order to understand these concepts, you need more background explanations. But when I read those figures, I hope to understand all the information that contains in the figures. If there are things that not understandable, that it creates a kind of a mental block in my mind.
Sure. Totally makes sense. So, and it's good to want to understand all the notation. So this is a representation that is going to come up again and again. It's the Markov blanket, and there's kind of two types of notation happening here. There's like the variables that are being locally assigned, and then there's some more conventional notation. So like some of the conventional notation is f is a function of something, and then omega is a noise term on something. That's conventional, and also the dot being rate of change. So it's kind of like having like a prime or a first derivative. And then there's the locally assigned variables. So external x, internal mu, octave u, sensory y. And then now there is a typo in this figure, a small one, just it's in the errata. Okay, but the visuals are correct. Each of these functions, the rates of change of each of these four kinds of states, we're describing the rate of change. So it's kind of like a flow map for all four of these nodes on a graph for the internal, external states in the blanket.
Right.
Rate of
So
change.
Right.
And each of those rates of change is broken up into two components, kind of like a signal and a noise. That's
Okay.
and noise could be zero, or it could be all noise. And then
Right.
the signal component on the rate of change of each of the nodes in this particular partition, the signal component is a function of all the incoming arrows and itself at that time.
Right. So in chapter 2, we understand the low road. We understand the active inference as a kind of an optimization problem where you have a choice of action and perception. So how does action and perception play a role in this figure, in this Markov blanket, in the figure you just showed?
Yeah, good question. Well, we associate this incoming sensory state according to perception, and then the outgoing statistical dependencies according to action. And then what happens here, which could be nothing if it's a very simple system, or it could be sophisticated or unknown, same as external. We just call this the cognitive states. So this is the perception, cognition, and action of the agent. Blanket plus internal states, that's the particular thing insulated off from the external states. So that's why this is like the minimal Bayes graph for the cybernetic agent, is having the input, cognition, and output. And the work of Isomura and Friston and others like maps this onto neural networks that have like a input, processing, and output layer.
Right, but I'm thinking, where are the choices? Because in the chapter 2, it talks about the perception and the action are the choices made by the agent or organism, right? So those are the choices, not the states. And it's a decision, kind of decision you can make. You can choose to perceive this way or the other way. You can choose to take that action or another action. So here, are you seeing the action state is the action is a choice?
Two ways to think about this. First is, that's why we talk about beliefs about action prior, policy prior, policy posterior. So because we're talking about our beliefs about action. And the second thing is, this is coming from a high road. So this is kind of like a forget what you knew about chapter 1 and 2. start with just this particular partition on a Bayes graph. And then the chapter continues with connecting it more to perception and action. But start with like, this is the topology of systems that can sense and act. Or you could propose a different topology of that system. Young-hoon, and then anyone else.
I just wondered, so the sensory states are the perception and the active states are the action intuitively. And well, those two are directly connected to each other, and which means that they can bypass the cognition. And it's really hard for me to imagine a state of active states just bypassing the cognition and just going directly to the sensory state, and also vice versa. So can anyone come up with a good example of it?
Awesome question. Does anyone want to give a thought on that, about this? What is this double-headed arrow in the center?
So my understanding, this arrow means that the active state is affected by the sensory data you connect. So basically, you can see here, FU is a function of Y. Y is the sensory data that the agent gathered from the external world, gathered from the expectation. And on the other hand, also the U is your action, also will affect your sensory data Y. For example, in the chapter 2, the apple and frog example, if you choose your action to look at an apple tree, that's you. If you move your eye towards the apple tree, that will generate sensory data about apple. What you observe will be an apple. So that will be the action will affect your sensory data Y. And your sensory data Y will affect your action. I'm just thinking how that example.
These are all true. Another thing to keep in mind is like the effect of a given edge in a model or system of interest. It might not be relevant, but it's kind of like in principle. So if you have a computer system where one computer is getting input and sending it to a second one, sending it to a third one, and then emitting it, there is no effect of this arrow. Or if you have some, some other system where this in practice is zero. So just because there's an edge doesn't mean that in that simulation or that model, it's like it matters in a certain way. And the reason why it's there in principle is because the definition of the Markov blanket for a given node is all the nodes that kind of insulate it and the co-parents. And so just in principle, they could be connected under the Markov blanket definition. Like the Markov blanket nodes could all be connected to each other and be connected into the node of interest. And also these assignments of internal, external, active, sensory, these are all relative to a given internal node of interest. If you called this one internal, then this would be sensory and that would be active. Or if you picked one over here, it would be different. So these are not like essential features of nodes. These are just with respect to a chosen internal state on a created model. Darius?
Yeah, I mean, just staying on the Markov blanket for a bit. I've seen quite a lot of conflicting literature and opinions on to what degree it constitutes a metaphysical reality. So I think one can't help but think of a kind of cell when you think of a Markov blanket, and the blanket states that are the boundary between the cell and the external environment. To what degree are Markov blankets from the biggest Markov blanket, a universe within a universe, all the way down to the smallest of Markov blankets and all the ones embedded in between? To what degree do current free energy principle theorists believe that there's a genuine metaphysical reality, or is it just a way of visualizing and understanding statistical regularities?
Yeah, big question. What does anyone think? Ajit or anyone else?
I guess like I would think it would so would that be connected to like our subjective experience would be this statistical model, so that would be the Markov blanket? Is that what you mean? Or I mean, does that infer like
I don't mean that it's observer relative. More that you have the universe as is, and our observations indicate to us that there are separate patterns of existence, things that are distinct from one another. Are those boundaries, which are defined by the Markov blanket, metaphysical as in they exist? I mean, I think the only way of kind of conceptualizing that is as a material distinction. Or do they just exist? Do they solely serve to be a statistical representation of the actual distinctions that we observe, but perhaps there is no physical substrate underlying those regularities? That's my question.
Yeah, it's a huge question. There's a ton to say on it, definitely a lot of perspective. So like there's a way broader range. One topic that comes up in that setting is the different flavors of instrumentalism and realism and scientific realism, pragmatism. So instrumentalism is like the least metaphysically committed and just says, look, linear regressions help us understand the relationship between this and that. That gives a sort of cognitive realism to the linear regression. It might influence someone's life, so it does matter. So that doesn't mean that we don't take it seriously, but no one is going to mistake the map for the territory. Then for various reasons, there's also more of a realist, not necessarily like a Platonic realist, but like a scientific realism. It's like, yeah, the objects that are under study are real. Now the finger isn't the moon, so pointing at the phenomena, it's still like not map territory. The model and the equations is not the system. That's obvious. So just saying, but the model doesn't have this feature of the system is like, yes, but we're talking about the reality of this system. You know, 6 people and the elephant, they can still be talking about the reality of the elephant. So that's kind of a scientific realism. And Mel Andrews' work and the math is not the territory, Livestream 14, and a lot of other discussions on that. And then there's a lot more to say, but that's a great question area. Bryn?
When I read this chapter, I mapped the example that I thought, or I intuitively kind of found helpful was playing the piano. And I wondered if you could verify the veracity of that example, if it doesn't indeed explain many of the dynamics between my internal states, my active states, the hidden states, and in turn, the sensory states that I receive to complete an action kind of feedback loop. And I think it also might explain the edges between the active states in the example of playing the piano and the sensory states that might ensue should you take a particular action, or in this instance, as I hope to explain, not take a particular action. So I thought of the piano, kind of sitting at the piano with the intention of playing, and I believe I want to play piano. I'm not 100% certain of what might fall under, you know, what would fall under the internal states, but other than a belief that I can play, I'm sure there are many other factors there that would be necessary for one to initiate the action. But then I touch a key, a note, and that entrains an effect on the perception of the piano, which then in turn, I don't play that note directly. I elicit sound from the piano, which then in turn gives me the noise, which hopefully sounds good. And so I continue that effect by playing the next notes in accordance with the previous one. And so I build a tune as I go, hopefully. And hopefully that's pleasing rather than full of kind of dissonance and offbeats and irregularities. And I thought about the relationship between the active states and the blanket states, the sensory states. If you were to omit a note, thereby inhibiting the effect of the action on the piano, thereby you won't perceive anything in its, you won't get anything in return, so to speak, from the piano because you have omitted a note. So yeah, I kind of thought about this around playing the piano. Yeah.
Awesome. That's a really cool example. And in chapter 7, there's going to be like a musical example. And
Yes.
music cognition, there's a lot more work on as well. But in this example, like the wrong note is played, quote, wrong note, different than the expected tune, but the expected note is still heard because the
Yes.
prior is so strong. And so like Ali and several others have a lot of interest in that music perception. It's like very rich with music perception and generation, improvisation. It's a really cool area.
Daniel, if I can just ask, if you can go back to diagram 3.1, I think it was, I just wanted to clarify something that's just come to mind now. I'm not very good at all the technical details yet, but how is the noise from the external state, how does that relate to, or how does it correlate to the impact or the effect of the noise at the sensory state? Is it how is that kind of transduced? I'm thinking of the piano example again. How does that dissipate through the system? Is it equivalent? So a particular noise at the external state, how is that experienced or understood as, how is it similar or dissimilar from the noise perceived at the or generated in the sensory state?
Yeah, very interesting question. So think about each of these 4 nodes as being like a sensor or a thermometer in and of themselves, like they're probes that are tracking these flows. So what would it mean to have this be high and this be low? Well, maybe the temperature in the ecosystem is constant, but it has a lot of variability. So there's like no signal really, but there's a high variability, but we have a very accurate thermometer that we're taking in information from. Or conversely, maybe it's a deterministic temperature outside and our thermometer is highly variable. So this is kind of just like the outline that gets filled in like 100% during the modeling process. But this is just extremely general outlining like where the signal, just saying that each of them are partitioned into a signal and noise component in principle. But that's why it really helps to also to think about specific examples and yeah. Younghoon, or go ahead.
Oh yeah. Like because I'm a psychiatrist, what what keeps to my mind about this Markov blanket is that it's really a cool concept if you think of the process of psychoanalysis, because like the therapist, by using his own internal state and inferring the internal state of the patient, and then by making decisions and influencing the sensory states, active states, to change the internal state or the internal model of the patient. So, I mean, that's quite interesting because like the basic concept of Markov blanket is that you can't really have access to external states, which means that you don't have any access to the internal state of others. But you can change the internal state by having very good inference about it and doing the right active actions or providing good sensory states, like maybe making the patient comfortable. Or sometimes you use many different techniques with psychotherapy, such as hypnotics or I don't know, maybe other relaxation techniques. So, well, the basic concept of Markov blanket is really cool for me. So, like, it wasn't a question; it was just a comment.
That's awesome. Thank you. That is absolutely the core of the Markov blanket concept. Definitely a lot of philosophical, like smoke and fire is in that area for I think a variety of interesting reasons, partially because it touches upon like how things really are in some people's eyes. Or it's something that seems to explain like everything and nothing, but at the end of the day, it's just a description of the sensorium. And the real important missing the missing piece, or the missing edge, not missing piece, that really embodies the constraints here is the no telepathy, no telekinesis clause. No edge between internal and external states, except via insulating nodes. So by making a fully insulating shell, then you don't need to make any claims about what's in the on the other side of the blanket. Now you might happen to know, or you might have a really good model of what is happening or something like that. But those models aren't free. Information takes energy. And they're always understood as projections of onto hidden states or trackings of hidden states. So it's really just a recognition of the sensorium and the cybernetic system boundaries, with actually a lot of generalizations that make it really exciting and even more flexible than people might initially consider just from looking at this relatively simple system. Darius?
Yeah, I was wondering, this makes perfect sense to me in terms of a sentient non-steady state equilibrium system like a human brain. But if in terms of this equation, in terms of the Markov blanket generally, but to what degree can we think that entities that don't act, that exist in steady state equilibria, so, you know, like Friston's classic example of a drop of oil in water, I understand that you can't necessarily attribute action to the drop of oil, or at least purposeful action. When we look at that diagram in 3.1, do we have to think of it as if the drop of oil, it's as if they're behaving in this manner? Or are we committed to some notion, of course, the external and the internal states, but that in maximizing its model evidence, it actually is sensing and it is being active? So where is the kind of dividing line here between sort of sentience and non-sentience, and to what degree, and if there is one, is it just that the drop of oil basically exists, it just seems to be maximizing its model evidence, but there's no real telos to it? Yeah, that, because the action here, the active inference, seems to me to be very highly linked to sentience.
Yeah, great questions. Well, one angle is an instrumentalist goes into that area without feeling like they're taking on descriptions like it's a sentient as they extract the signal of. So it's very like relational or sort of like perspectival view on sentience. Whereas somebody taking on more ontological commitments would say that they are exploring or characterizing the true nature of sentience or intelligence. Here's a really early, like 2006 or so image from a Friston paper. This is the winged snowflake. And it's like systems that persist conditioned on seeing this snowflake. It's not conditioned upon all possible, a room that's 100 degrees C. Conditioned on seeing this snowflake, there's going to be snowflakes that through wind blowing them around, so just doing no better than you'd expect from the wind currents, or doing better than the wind currents, they preclude phase transition of melting. Once they cease to exist, then they cease to exist. So that's like one. And then because you asked about how to describe these simple systems too, and then this path integrals paper made the clearest taxonomy of systems from inert systems where like some of these nodes are trivial. So some of these nodes can be trivial or null in effect. And that's what gives the ability to model a really simple system. But then the composability of the Bayesian graph format allows the construction of also more sophisticated cognitive models, all keeping the Markov blanket condition, because you could have internal states could just be like a pass-through, or you could like imagine they functionally didn't exist, or it could be this, or it could be that. Andrew?
I just wanted to add to that I mean, in the chapter itself, later on, I guess, section 3.6, page 56, they attempt to kind of provide their own answer to the distinction between like a sentient or perhaps non-sentient organism. And they just say this is one answer. So not, an exhaustive answer to the question, but like having the capacity for an organism to have the capacity to model alternative futures and to have that level of temporal depth. That's one answer that makes sense to me in thinking about like the drop of oil in the water. Like perhaps it is, it's reacting to something like sensory input and acting, but nonetheless, like I can't imagine that the oil is, anticipating future sensory information and coming up with its own representation of the proper action to take in the future and what it should be moving towards. So that's kind of how I viewed, a way of deriving an answer for the sentience versus non-sentience question.
Yeah. Cool thought. And yeah, like an inner object or even a simple active object may not provide any evidence. Like you don't need to appeal to any counterfactual generation in order to explain even potentially lifelike behavior in certain, basal cognitive behavior may not need explicit entertaining of alternatives. Wanshun?
Yes, I have the question about the figures, about the direction of the arrows. Can you go back to the figures? Figure 3.1, right? So if you look at here, there are on the upper right, there is a two direction figure between active states and internal states. What I'm thinking is that the internal state will affect the active states, right? So what action you take depends on your internal state. But how does active state actually change the internal states? So
does anyone want to directly? Yeah, totally. Does anyone want to directly?
The internal states will be affected by your sensory states, right?
this isn't
Also,
what
the
does
sensor
happen.
states.
This isn't what does happen in a given model. This is what can happen in one arrangement of an abstract Bayes graph. So don't connect it to the actual structure of causality even in the world. This is just saying this is like a template sketch of a cybernetic agent with, and what's mainly ruled out are the telepathy and telekinesis. And the other one that you can think of as ruled out, instead of asking why this is two-edged in principle, what's ruled out? Backwards causation of action. We want to be entirely in control of action. And backwards causation of sense states. We don't want to have our thumb on the scale. So there's just many, many ways to think about it. And in any actual modeling situation, this level of abstraction is not engaged with. It becomes a lot clearer when you're talking about specific functions describing different states in a specific system of interest. Younghoon?
Oh yeah, it's a totally different question. But like considering the reinforcement learning, sometimes when you sample a lot of sequences and then like there are some models like Tolman Eichenbaum machine or successor representation, which actually updates the state to state transition based on the experience that you had. It even though you don't really perceive additional information, you can update the transition metrics based on your memory. So you replay and play back the memory, and it actually updates your internal states. So considering that fact, where should we put the memory replay in that figure? Is it like, do we have to say that the memory replay is some kind of action, or is there another alternative solution?
Great question. I'll just try to set it up indirectly because I think it's a real direction. Is there's going to be kind of two ways, main families of ways of representing the cybernetic agent that we're going to see. One of them is this Markov blanket type. So here it's like a very physics based. That's why we're coming from the high road with the free energy principle, because it starts from this kind of like flow of physics space. The other representation, which we saw in chapter 2 and gets used in chapter 4 and so on, is this Bayesian generative model. But like you don't see the internal, external, and blanket states, though here's different notation, but they're both ostensibly about the same active inference agent, right? Where one can view the observations here as the sensory states, and then one can understand that the actions taken have causal impact on the world, but that's reflected by the B matrix and learning on the B matrix, learning how actions are associated with changes in the world. So when it's coming more from like a high road perspective, that's more in the physics, and that's where you see more of the physics type formalisms. And then in more of the decision making and signal processing area from the low road, that's where we see more of these like just not physics based in principle Bayesian methods. There's probably a lot more to say about that and other ways to say it, but like this representation is about a cybernetic agent. Also, this representation is about a cybernetic agent, and they meet in active inference where those models have some relationship. Okay. Figure 3 point, or does anyone else want to make a comment or question?
Yeah, I wanted to just follow up on that note. So if we look at equation 3.2, very similar to equation 2.5, except in 3.2, variational free energy is contingent on a model. So I'm trying to relate that with the previous comment about the cybernetic unit and the Markov blanket. Is that related to the model, the contingent model?
Yeah, exactly. So free energy, like expected free energy, variational free energy, it's a quantity about a model. Like sum of squares is a quantity about a given linear regression that you might do as like an error term if you're fitting a regression. Variational free energy is like an error term that is about a specific model. I mean, if you put another node, you made a different model, the free energy would be a different number. If you didn't have a model, a map, then you can't calculate a free energy for a model that doesn't exist. So it's a descriptor of a map. So everything is really conditioned upon the parameters and the values that are in that specific model. That is, yeah, Darius?
Yeah, just maybe a point of clarification for myself. I presume it can't be entirely internalist, because at least just like looking at the KL divergence in the equation, the difference between the approximate posterior and the true posterior requires some commitment to there being an external state that you're trying to predict. So where is that just, you've got the variational model, so you've got the variational free energy, which is tied to your model, but ultimately it's also subserved by the fact that you are an agent in the world and that you're making Bayesian inferences about the world, and it can be closer to the real world state or not. I just don't know if I've got that the right way around.
Yes, that's true. And the KL divergence gives us this optimizable, incremental way to update our beliefs queue to bring them to where they aren't moving anymore, just as just a first approximation, where we can't believe any better about perception or action or cognition with respect to, as you pointed out, the underlying true distribution. But this can be understood in practice as just not wanting to update your belief and achieving preferred states, which is the maximum evidence model for the incoming data. If you literally knew what photons were going to come at you next, and that is minimized surprise. So this is kind of just like these three parts are they're being equated here, but they're different framings. This is saying this is the most performant model, best model evidence. This is the least surprising model. If you knew how much to be surprised, you would have the best performing model. This is a well understood relationship. This is saying because of how free energy is defined, which isn't invented by active inference, look up energy-based method or evidence lower bound. This quantity is tractably optimizable. And if we can reduce the divergence, where there's the KL divergence shrinking, we'll be doing strictly better. That doesn't mean good enough necessarily, but strictly better towards this situation. Wanshun?
Yes, I have the question about this model concept. Does the model refers to all those dynamic equations in figure 3.1? What do we mean by model here?
Here?
Yeah.
The model we
is
have
3.1.
about how Y are generated.
So it could relate to everything in figure 3.1, including like the because Y is generated based on your internal state, based on external state, right? Also, it's also affected by the active state.
Yeah. If you had the total understanding of what photons would come next, including how the world changes and how your action influences it, this is like an agent level loss function for understanding how Y are generated. But you could use energy-based methods on any Bayesian distribution. But this is just introducing an important relationship amongst surprise minimization equals model evidence maximization. That's the first part. And variational free energy is a well-used method to tractably optimize this interface.
Right. So in 3.2, QX is a decision variable. So to minimize, or to maximize, you want to minimize, right?
Well,
so
QX is the total beliefs. Those are the beliefs that we control. But take it again from just this level of the high road. So not explicit counterfactuals yet, just flow across these four states.
So the generation of Y actually are connected in all those four equations or four states, right? How those four states are changed. How those four states changes. So M refers to all this process, how this process are described.
Yeah, M could be a linear regression and Y would be the data. And then we'd say the surprise is minimized, the evidence is maximized, and the variational free energy is minimized when we have the model and the data, and the model's as good as it can be for the data. So it's the exact same thing. Like the two pieces that come into play here are the model and the data.
Right. So the decision is your QX, right? So it's a function.
It's not just the decision though. QX refers to all of the optimizable beliefs, not just about action.
All right. So it's a belief that you may choose to minimize your total surprise, right? Or to minimize your variational free energy. So among all QX, you choose one to minimize this expression on the right side of 3.2. Is that right?
Mm-hmm.
So QX, what is X here? X, does it refer to the internal state of the mind?
X is the external states. Those are the hidden causes about how Y are generated. Figure 3.1, X, external states, how sensory causes are generated. No thumb on the scale. Only the external world causes sensory states.
Okay.
So the generative model of sensory states being produced as they are, maximize your evidence about incoming data, minimize your surprise about incoming data, minimize your variational free energy about incoming data. All of those are causal modeling of external states. Analogously to how internal states are like doing that for action. Because which one you call internal and external, you could flip and do the other one. At this level of generality, not when you actually build a model, but there's still nothing that's really fundamentally different between internal and external, other than which side the modeler chose to do internal. Darius?
This will be my final question, I promise. I just wanted to ask about the kind of architecture of the generative model. So the agent is constituted by the internal states and the Markov blanket. And the agent, this was in Ben White's talk as well, this point of potential conflict or confusion that the agent has a generative model or the agent is a generative model, and that generative model has priors based on its optimism bias of what of the preferred states, the attractor states it wants to be in. Is it that, can we consider the generative model therefore the internal states which are encoding beliefs about the world and the Markov blanket? And in that case, how could you say, if it is that, why would you say that the agent has a generative model? And if you do hold that, if you hold that claim, what's extra about the agent beyond the generative model?
Yeah, those are great questions. Well, what's extra about a person beyond their health record, which you do a linear regression on? I mean, the territory itself. So that's the instrumentalist answer, is this is all just about the model. We're just talking about Bayes graphs and statistics. So we're obviously talking about maps, not territories. So that's, again, trying to take on minimal commitments. But the question about, like, does it have a generative model or is it a generative model? Well, if you're talking about a software agent you designed, they might be the same thing. You might say it literally does active inference because I actually have it implementing that. Here's the script. But if it isn't literally / actually an active inference simulation, it seems like you're going to be in the situation described in figure 9.1. So you're building, this is the figure 4.3 generative model for the subject of a behavioral experiment. That's why it's subjective. It's their perspective as the mouse in the maze or whatever, but it's also like they are subject to the behavioral experiment. And then here's the outer loop. So would you say that the mouse is the cognitive model that the researcher made? Probably not. So in practice, a lot of this, like, metaphysics doesn't come into play. When you're talking about a specific generative model, it's a lot clearer that it's just like a very hopefully well designed, but just a reduced model of the system of interest. That chapter 9 is about, like, this kind of empirical modeling. Ninky? Oh, I cannot hear you, actually.
Can you hear me now?
Yeah, go for it.
Okay, great. No, I have a question that's very much related to that. I think there are lots of sort of general comments about the systems to which we can apply active inference, and what sort of the specific formal criteria are to describe a system as adaptive. And I'm also very much interested in these philosophical perspectives and seeing sort of how, in which sense you could view a whole organism as sort of following the principles that's specified by active inference, or in which sense you could sort of use active inference to describe maybe systems that are lower within that hierarchy, that are maybe like smaller regulatory systems in the body. So I was just wondering if there's any sort of research on sort of the general applicability of active inference as sort of a way to analyze adaptive systems. And I think a lot comes down to the mathematics, which I don't fully understand yet, but.
Well, awesome question. That's very cool. One direction of research that comes to mind is like, here's a 2019 paper. So there's been a lot since then, and a lot more integration with active inference too. But some of these representations of multi-scale systems, nested systems. So being able to, in like chapter 5 in the textbook, there's going to be like a motor circuit that's influenced by a higher order decision-making circuit. So then you may be able to sketch out some of those lower level units.
Okay. Which paper was this again?
I'll put it into the chat.
Thank you.
All right. Well, cool. About chapter 3, I guess if next week or next week at the other time, we'll come back, and if people can have added or voted on different questions, and we'll talk more about the questions next week. So thank you. See you all.
Thank you, Daniel.
Thanks, Dan.
Bye.
Thank you.